thermodynamic coordinates or thermodynamic variables. The thermodynamic system is specified by the thermodynamic coordinates or variables such as pressure, volume, temperature, entropy, etc. That means in order to specify a thermodynamic system, we need some coordinates, and these coordinates you are calling as the thermodynamic coordinates or thermodynamic variables. Next is thermodynamic coordinates or thermodynamic variables. In order to specify a thermodynamic system, we need some coordinates or variables, and they are known as the thermodynamic coordinates or thermodynamic variables. And the quantities or variables we are using are pressure, volume, temperature, entropy, etc. And the thermodynamic coordinates or thermodynamic variables or thermodynamic parameters are classified into two: intensive quantities or intensive parameters and extensive parameters. Our next topic is thermodynamic coordinates. The thermodynamic system is specified by thermodynamic coordinates or variables such as pressure, volume, temperature, entropy, etc. That means in order to mention a thermodynamic system, we need some thermodynamic coordinates, and you are calling that coordinates as either thermodynamic coordinates or thermodynamic variables or thermodynamic parameters. These are the common names. And the quantities that we are most commonly using are pressure, volume, temperature, entropy, etc. And the thermodynamic coordinates you are mainly classifying as intensive thermodynamic parameters or intensive thermodynamic quantities as well as extensive quantities. Intensive and extensive, and this term is also familiar to you. And the extensive quantities you are defining it as thermodynamic quantities which depend on mass and size of the system. Examples are volume, entropy, energy, etc. That means these quantities, that means extensive quantities, depend on the mass and size. As an example, if you consider the duster that we are using in our class, if you are making it two halves, you can see that the mass of the system has reduced. Then you can see that the volume has also reduced. So volume depends on the mass. Similarly, the energy possessed by the duster before cutting it is not same as that after cutting it. So these type of quantities which depends on mass and size are known as extensive quantities. And now you have intensive quantities. They are defined as quantities which are independent of mass and size of the system. Examples are pressure, temperature, density, etc. So, if you cut a duster, you can see that the pressure that acting on the surface of a duster is the atmospheric pressure. Whatever be the size, the pressure is same. Similarly, the temperature. So, these are intensive quantities. And now we have seen that the quantities intensive and extensive. Intensive is independent of mass and extensive depends on mass. But what is the need of the term size? That we can make clear. Suppose you have a balloon, that's a simple example, and inside that balloon you have some mass. So if that balloon which is a closed system, that means which is tighted. So if it is heated up, you can see that you may consider the balloon as a spherical one. If the size of that balloon has increased, you can see that mass remains same, but volume has changed, volume has increased. So if we have a definition only that a quantity which depends only on mass, there you can see that your volume has increased but mass remains constant. But what actually happened is the size has increased. That is why we are incorporating the term size in addition to mass. So quantities depend on mass and size are extensive, independent of mass and size are intensive. Now, when we are studying the thermodynamics, we have two different approaches for the studies, and they are the macroscopic point of view and a microscopic point of view. So, to describe the behavior of the system or its interaction with the surroundings, 2 points of view may be adopted, and they are macroscopic point of view and a microscopic point of view. And from the terms itself, that means macroscopic means something which is large, and microscopic means which is very small. In the macroscopic point of view, we consider the variables or characteristics of the system at approximately the human scale or larger. That means you will consider a system as a whole and not as its individual particles or molecules. That means we have the larger concept. And in the macroscopic point of view, the system can be described by specifying the macroscopic coordinates like mass, composition, pressure, volume, temperature, etc. So these are the macroscopic quantities. And in the microscopic point of view, the variables or characteristics of the system are at approximately the molecular scale or smaller. And in the microscopic point of view, the system is considered to consist of an enormous number of molecules, each of which is capable of existing in a set of energy states. Means you have I think you have studied the kinetic theory of gases. There you have studied that molecule can be in any energy state which is in random motion, etc., such that so there you are considering the each and every molecules, and to find some quantities what we need is you have to find what is the average of all these molecules. So that is why we are calling it as it is an average study. So again now we can see that the macroscopic coordinates, they involve no special assumptions concerning the structure of matter, fields or radiation. That means if you are using a gas, liquid, solid, whatever may be, you are not at all interested in the nature of molecules which is building up the system, and only few number is needed to describe the system, either pressure, temperature, volume. It is enough, and they are fundamental as suggested more or less directly by our sensory perceptions. This is an important point. These quantities referring to our microscopic point of view, they have some physical, that means they can be sensed by our sensory perceptions. For example, suppose you have a hot water and cold water. By simply dipping your finger, you can distinguish the temperature difference, or you can have an idea of the temperature. Similarly, volume, mass, anything that can be actually you can't be a exact measurement, but if widely separated quantities, a small one, a large one, all these can be easily made by our sensory perceptions, and also they can be directly measured. That is another thing, they can be directly measured. And thermodynamics is the branch of natural science that deals with the macroscopic properties of nature and always includes the macroscopic coordinates of temperature for every system. So in thermodynamics we are using the macroscopic point of view, and the presence of temperature distinguishes thermodynamics from other macroscopic branches of science such as optics, mechanics or electricity and magnetism. And regarding the properties of microscopic coordinates, assumptions are made concerning the structure of matter, fields or radiation. There we are interested in the structure, that means we must know the molecular properties. Many quantities must be specified to describe the system, and these quantities specified are not usually suggested by our sensory perceptions, but rather by our mathematical models. As I have already mentioned, for a system we have mentioned that you have so many molecules and they are moving with the different velocities. So what you are considering is you are taking some most probable speed or root mean square speed, etc. And this root mean square speed, etc., they cannot be directly measured by our sensory perceptions, because you can't see the molecules, and if you have to actually you have to measure each and every molecule's velocity, you have to take the average, etc. So there what we are doing is we are taking the average, that means the statistical average, and they cannot be directly measured, that means you have to calculate them. And statistical mechanics is the branch of natural science that deals with the microscopic characteristics of nature. That means you are taking the average or the statistical properties.